I just want to test to ensure everybody can hear me. If you can hear me, give me a thumbs up. In the chat. I want to remind you that the meeting is being recorded, and in order to maintain the quality of the recording, we would like to have everybody have their mics on mute. Once you enter the room, your mic should be on mute. If you do have a question and you would like to ask over the mic, you can raise your hand. Otherwise, I would prefer if questions are asked in the chat, and we will answer the questions or concerns in the chat. It's almost time for us to start. Yeah, you're not going to see me because I have not turned on my videos yet. Okay, good day to everyone. I trust that everybody is doing well and you are keeping yourself safe and COVID-19 free. Our class today is going to be a bit different from the classes that we've had in the previous sessions. If you have gone through, I trust that most of you have gone through, but if you have gone through the unit for this week, you realize that there is a lot of content. There is no way that we are going to go through all of this content in 1 hour. Okay. So what I want to do is do the session almost like a review session. But I also want to look out for your questions, concerns that you had as you went through the content so that we can clarify any issues that arose as you went through the content. I would advise you to keep things organized. I would advise you to ask your questions in the chat so that whoever has to look at the recording, things would be clear and very understandable. Okay, I hope that everybody can hear me, and I hope that you can hear me clearly. I want to remind you that we are not doing much video apart from what I am going to broadcast at the top, because in the past, whenever we've had several video streams going, we started experiencing bandwidth issues. So I just want to remind you of that. So pay attention to whether your video is on or off. Pay attention to whether your mic is muted or unmuted. These are important because several persons are following, and the recording will be available to persons who would not have been able to attend the class. And we want that recording to be of a certain quality. So thank you very much for adhering to these simple rules. I want to begin the class. I'm going to go to our online platform, and I want to start looking at the content. I am going to be asking a lot of questions because I prefer class where there is a lot of interaction as compared to me coming and standing on my soapbox and talking for an hour. Okay. And I think the interaction brings better understanding to students than if I am just in a presentation mode. So I want to encourage interaction. I also want to encourage you to use the forums on the online platform. Use the forums, post questions. If you're going for content and there is something that you had seen before, heard before, but you never understood it, and you finally understood, you could post something about that, that's something we call a reflection. We could post something about that in the forums, the discussion forums. If you realize that a piece of information that you got from the class, you realize how you're going to use it and how that's going to improve your work at your utility, you can post about that as well. So I want to encourage the general discussion. I want to welcome, I saw Mr. Gill on the list. I want to welcome Mr. Gill. I just saw Mr. Daniel. No, Mr. Gill isn't there anymore. But I just saw Mr. Daniel and I want to welcome him. Class is joining us today. Of course, he's the tutor who did the math and he will be doing a few other sessions. It's the two of us who will be manning most of what has to be done in terms of tutoring and in terms of giving feedback. Okay, so he's here with us, Mr. Gill. Welcome. He just showed up here again. So we begin. So as I said, it's going to be a different kind of class. Okay, so we will be doing things differently than what we have done in the past. So I want to start off by asking a question. I want to ask persons to give me some of the components of a distribution system. So as I said, you can type that in the chat. So I'm waiting for persons to give me components of a distribution system. I see valves, pumps. Nice. Pipes, yes, very important. Tanks, storage, very good. Okay, so these are some meters, very good. Now pipes, we can separate pipes into, we have our transmission lines, we have our distribution lines. So we could look at some different types of pipes that are on the systems. I see hydrants, very good. Some persons are specific about the types of valves. Okay, the water treatment plant is also part of a water system, and the distribution system is also part of that water system. Okay, so according to, if we look at, there's a PowerPoint presentation. Well, not quite PowerPoint. Yeah. There's a presentation here that goes through. Let me just run through the introduction. All right, so this presentation went through some of the things that you saw about distribution system or water system in general, because the distribution system is part of the water system. So now that we have identified some of the components or most of the components of a water system, okay, the content on the site also goes through the three main designs or layouts that these systems have. Now, there is an error in the first one. It's supposed to be arterial, not aerial. That's a typo. So it's supposed to be arterial. So there's an error there. Um, so arterial loop system. We have the grid system, and we have the tree system, or sometimes referred to as branched. I want to know what are some of the characteristics of these three systems. Let's start with arterial. Can somebody tell me what are some of the characteristics? Are there advantages, disadvantages? How does water get into the system? So you can, I'm giving you a choice here. You could either raise, if you raise your hand, you can do audio or you can type in the chat. Let's get some audio. Some audio might be nice. So let's get somebody to respond over the mic. I'm waiting. Oh boy, no mic's working today. Should I volunteer somebody? Okay, that tells me something. All right, in the interest of time, I'm going to move on. Okay, so we have these three, and the first one, the looped. If you had gone through the material, okay, somebody's asked me to repeat the question. I wanted somebody to tell me what are some of the characteristics of the looped or arterial looped design or layout for a pipe system. Okay, what I will do, when I ask a question, I'm going to give 30 seconds to answer because we do not have all the time in the world. And if within that 30 seconds, nobody answers, I'm going to continue. So the arterial loop, okay, if you look at the diagram on your system, now on your system, you would be able to get this in full screen. I am not sure why I'm not getting it in full screen on I'm using my tablet, I'm not sure why. Okay, but the arterial loop, one of the disadvantages, well, not disadvantages, but the advantage is that you have water coming in from at least 4 different points. So water is supplied from at least 4 different points. At any point in the system, water is coming in from these several points. So you have good flow, and they use large diameter mains. So this is a system that is good because you don't have what we call dead ends. And when we speak about dead ends, we are talking at points in the distribution system where water basically does not flow through. It comes to a dead end, like a dead end road. And what the problem with that is that you have chances of the water becoming stagnant, basically becoming stale. And very often we have taste and odor issues, odor problems at these points in the distribution system. And the quality of the water, the microbial quality of the water can drop because what tends to happen is your chlorine residual can go down at these points since the water there is not circulating. Now, if you look at the grid, The example given here, we have 2 points where we have mains of water coming in. So what happens is, since we don't have dead ends, the likelihood of, since we don't have dead ends and water is coming from various points, the likelihood of getting dead ends is, or these issues, is much smaller. Then we have the grid system, which is similar to the loop, but the point at which the transmission line is different. Okay, so these all the means are interconnected. So everything is interconnected. So we definitely have flow in several different directions, and so we basically reduce the possibility of dead ends. You could say to almost zero, because water is coming from several directions, all pipes. So water is flowing through all pipes. So you have no point where, unless a valve is closed, you have no point where you have stagnation. Okay? Then we have the tree system, and the tree system is notorious for having many dead ends. You think of a tree with branches, and branches are just going off, and branches don't connect to anything else, they're just in midair. That's the idea behind the tree system. So because water is not coming in from several points, you have many dead ends. And so these systems tend to have issues with taste and odor. They can have issues with taste and odor, and as well as microbial quality issues. Also, these systems are going to have low flow. Okay, so these are the three types of layouts that we have that are generally used. One of the things we can point out here is that very often you have a tree system where you have a lot of, like you might have a system that's already set up, and then you have a lot of unplanned additions to that system. Very often what you end up with is a tree system, because you're adding a connection here, you're adding a connection there, and when you add in these connections, or these branches, you're not ensuring that all pipes are interconnected or anything like that. You just add it, it's happening at the spur of the moment. Somebody applied for a connection down the road where there's one house at the end, or one house somewhere there, and so you have a branch coming off the um, the main distribution system. Okay, since so this went through a knowledge check, I'm going to skip it. Okay, and we look at water mapping, but I want to move on to pipes. Okay, so this section looks at pipes, pumps, valves. Can somebody tell me some of the different pipes that are available for use in the water system? Okay, all right, so you can't see. So let me see if I could switch. Just hold on, let me switch. I'm going to switch from one device to another, see if I can go full screen for you. Yeah. Um, all right, so I'm going to go over here. Now let me add, I did not mention that, but I meant to. When you, I, I have created a YouTube channel where I am saving most of our recorded classes. On that YouTube channel, I have also curated a few videos from American Waterworks. There's a playlist on there that deals with topics for class 1 and 2. So for the level 1 and 2 certification, I have added that playlist to that YouTube channel. So when you go to watch the reviews, go to the channel and you should be able to locate a playlist with quite a few videos. Some of these videos are being used on the Kawasa platform, but I felt that it would be nice to have them as a playlist, so that, for instance, for revision purposes, or if you're away from the device, you could just be playing and listening. So you'd get an opportunity to continue to go through content, even if you're away from the device. So, okay, so I'm trying to load this presentation. I believe on the computer, it gives me a full screen. All right, so yes, I'm correct. So I'm going to share the screen here with you. All right, so can you see now? So let me get to the point. All right, so everybody should be able to see a bit better. So let me go for my answers. So, all right, so we have PRV, galvanized pipe, schedule 80, ductile iron, copper pipe, okay, HDPE, okay, some good answers, PVC, okay, some good answers. Okay. We don't generally use copper pipe in the Caribbean, but these are pipes that are used. And when we talk about copper pipes, they're usually used inside of buildings. They're not usually used on the distribution system. So these are pipes that would be inside of buildings. On the distribution system, we use pipes which we can get um, at certain diameters, whether we are going from a 2-inch pipe way up to 24-inch pipe, or maybe a bit larger, depends on the application. So we use pipes that we can get in a certain range. Um, and there are certain things that we need, certain prereq things that we consider when we are choosing these pipes. Okay, there are certain factors that we consider, because if you look at what happens in the distribution system, these pipes are, most times we put these pipes in the ground, and these pipes are expected to be in the ground for 20 years or more. Okay, and when we choosing pipe, we want to choose, have an investment. We want to invest our money in something that's going to last. So these are the considerations. We have about 4 or 5 of them. Yeah. First, we think about the thickness of the pipe. And when we talk about the thickness, we're thinking about the wall thickness. Then we speak about the pressure. What pressures can this pipe handle internally? What pressures can it handle? Okay. Because if the pipe cannot handle the kinds of pressures that we are going to put it under, then the lifespan of the pipe will be shortened. Okay. Also, the soil conditions in which the pipe will be placed. If the soil conditions promote corrosion, okay, and we put a pipe that is likely to be corroded, that has high corrosion possibility in that soil, without protecting the outside of that pipe, then what will happen? The pipe is actually going to deteriorate over a period of time, and in a shorter period than one would expect. Imagine as a utility having to dig up the road and having to excavate um, almost every year to change pipes because of corrosion. You can imagine what the cost of that is going to be. That would be exorbitant. Okay, so we want to choose pipes that can handle the soil conditions in which they're placed. Then we think about the pipe's impact on water quality. Okay, for instance, copper pipes, when the pipe is closed, over a period of time of several hours, especially throughout the night, the water dissolves some of that copper, okay? And that copper ends up in the water. Now, if the copper goes beyond a certain concentration, it is not very healthy, okay? So we have, for instance, the Safe Drinking Water Act requires you after to open the pipe and let it run, let the water that has been in the pipe run for a certain period of time before you actually use that water, okay? And there are other pipes, for instance, asbestos pipes, we have they kind of phasing them out in most areas because of the carcinogenic properties of the asbestos, especially if it gets chipped or if it gets little bricks in it, then that can lead to persons who are exposed getting cancer. So we think about how that the inside of the pipe is going to affect the quality. Another thing we think about when we think about the inside of the pipe is the smoothness of the inside of the pipe. Because the rougher the inside of the pipe, the more resistance it will have to the flow of water in it. And to measure, we use a constant to measure the smoothness of the inside of the pipe, which we call the C factor. So the C factor, and I think it's mentioned somewhere in this presentation, but I can't remember much time being spent on it. Okay, but the C factor gives us an idea of how rough or smooth the inside of the pipe is. The higher that value is, the smoother the inside of the pipe is. So at this level, you may not need to be able to calculate at level 1, but you need to be able to tell the significance of the C value and be able to interpret the C value in terms of saying, if the C value is very high, what does that indicate about the smoothness of the pipe? If the C value is very low, what does that indicate? So you need to be able to tell at least that. Now, one of the things that will happen as a pipe goes through its lifespan, the C value may change over the years. Because based on the properties of the pipe, you might have accumulation of things on the inside of the pipe, also based on the quality and what's in the water that you're using. Okay, you can have deposits from the water itself, calcified deposits, for instance, forming on the inside of the pipe, reducing the effective diameter of the pipe, as well as changing the C factor, which means the inside of the pipe is getting rougher. Okay, so that is important. The next thing we look at is the depth of cover of the pipe. And depth of cover, we're looking at how deep in the soil that pipe is going to be. For instance, we put a lot of our pipes, our pipes on the road, underneath roads. Um, and if we put it under the road, we want to ensure that the traffic that is going along that road has as little impact on that pipe as possible. Okay, so these are some of the things that we consider about when we are choosing pipes. So as you go through each one, it's going to tell you, I think on the next year, so it's going to look at the pipe, look at what sizes are available, what the working pressures, advantages, disadvantages. So I'm not going to go through each one right now because we do not have enough time to do that. Okay, but I expect you to go through it and to try to memorize some of what's there. Okay, so if it comes up, if a question that comes up, these are easy points to you. Okay, so I want to skip and go to hydrants. Um, so our stuff tells us what hydrants are there for. So fire prevention. The utility is responsible for the hydrant, and they are liable in cases of emergency. So providing water for firefighting needs is one of the key reasons why we have a water system. It's one of those. And so we must make sure that, for instance, the fire hydrants that are there, we have to make sure that they are working. So if there's an emergency, um, the firemen could actually just come, connect in open valve, and out whatever fires that they need to. And we expected to do maintenance, at least annual maintenance on these hydrants to ensure that they are working properly. Okay. And their specifications, the video that is attached, there's a link to a video here. The video looks at the various types of hydrants, which I am not going to go through now. It looks at wet barrel and dry barrel and so on, flush hydrants. It looks at them in a bit of detail, which you need to know, but it's not possible for me to go through all of that in 1 hour. Okay. You also need to have an idea of where hydrants should be placed. Okay, usually is it 2 feet, I believe, away from the curb. Okay, they're supposed to have some kind of flange at least, that's for the flush hydrants, at least 2 inches above the ground. And there are a few other specifications. Okay, usually on a street intersection, and there are specifications as to how far apart you put the hydrants and so on. Okay, but the video that's there goes through all of that. So I'm going to move to the next item, which is meters. Okay, the video, we have a wide array of different types of meters, positive displacement being one of the most common ones. Okay, the video also goes through some of these meters, discusses where they're used, which ones are used at the consumer level. Positive displacement is a very popular one for that, okay, because of its characteristics. Okay, so as you go through the thing, meters are very important, because if meters don't exist or they don't work properly, the utility is going to lose money. So meters have to be, we have to ensure that they are not under registering the water that passes through them. We also need to ensure that they are not over registering. Okay. So we don't want to overcharge people for water, but we don't want to give away our water either. Because at the end of the day, the balance sheet has balance. Okay. So this was it for hydrants and meters and so on. Are there any questions? Do we have any questions on anything you might have gone through? Okay, anything you might have gone through as you read through as you looked at the videos? Are there any burning issues that you had? Because this particular class, well, this particular unit is content heavy. So there are things that you must go through. There are things that you must try to remember. It's very content heavy. So if there are any issues, questions, I would like to deal with them now. Okay, question about worksheets. I indicated well, up to this morning, I indicated that I realized that many persons have not submitted their worksheets. And as a consequence, I am giving until Tuesday morning at 9 o'clock. So you have up to Tuesday next week, that's the 24th, I believe, at 9 o'clock to submit your responses to the worksheet so that we can go through them and we can send you feedback. What we will do, we will also post, once that thing closes and we have looked at your responses, we are going to post an answer sheet which will give you the worked answers. so that you can, if you went wrong, you could correct where you went wrong. I am not sure if Mr. Daniel wants to add anything here. Oh, okay, Mr. Daniel is not there right now. All right, so I have no questions, no burning issues. People only want to know about when the sheets are due. Okay, so in light of that, let's look at valves. Did I skip valves? No. Okay, so we have not looked at valves and pumps. Okay, but before we do that, this little diagram here goes through, it looks at the various types of pipes in terms of types of piping systems. So based on its function, not based on the material of the pipe, but based on the function that it performs in the water system. So we have our raw water lines, raw water transmission lines, and usually these raw water transmission lines are very large. That's where we get sometimes our 24-inch water lines going to our treatment plant. For instance, from dams, from very large lakes, from rivers, and so on. We have very large pipes taking our raw water to our treatment plant. In the treatment plant, we have what we call in-plant piping. That type of pipe is usually visible. It's not in the walls of the building, but it's usually visible. Can somebody give us an idea? Why do you think these pipes are usually visible? Why do you think they are not in the concrete like the service lines that are at consumers' homes? You can answer in the chat since your mics are not working. Okay, to see leaks. So if the pipe is leaking, it's easy to see it and it's easier to repair. If the pipe were not where we could see them, it means that we would have a leak inside of the building in the concrete, and that would be a massive repair if that were to happen. Also, the size of some of these